the assignment, you've got your 3 options. So if we just click on the introduction, we're going to walk through this together. And like I said, we're going to go through it. I'm going to show you what to do, what you can expect, and specifically what documents you should be downloading. So again, you're not going to be getting to this until I believe it is due on Wednesday, a little bit later in this week. But this way you can know what to do when you get there, right? So we're going to be talking about natural selection. They're going to give you an introduction, a little bit background, taking the lesson that you've learned, which is about natural selection in the previous lesson from this lab. And they're going to kind of give you a review, a little summary of what you've already learned. So it's going to give you some more information about natural selection. It's going to set us up for the situation. So for the situation, we're really going to be thinking about California. There are these things called orange-throated whiptail lizards. Kind of tells you how the California's human population is increasing. So the lizard's habitat is shrinking. So there's very little food source. And so because of this thing called urban sprawl, which just means that with the increase of the human population and people moving from place to place, more and more development is happening, right? They're building buildings. A lot of the time that means that they have to take up the ground in the habitats where these animals live in. And when that happens, they chop down a habitat and therefore they can no longer survive there anymore. So we're going to see what's going to happen to natural selection because of this thing called urban sprawl. So then one thing that you can download is the list for the student guide. That was on the second page of that introduction. And then it's going to kind of give you a PDF of what you are going to be doing. And it's going to give you all of the directions. So really keep this handy. This is like the big kahuna. This is like that big document that you're going to want. So again, to get to this document, what you're going to do is go into that lesson introduction for the lab, lesson 2.9. Hi, Aiden. And you're going to go ahead, read the scenario. And then on that second page of the introduction is where you find this link. And that's going to give you the directions for the lab. Okay, but let's go ahead and take a look at the online, what it tells us the rest of it. Okay. So if you haven't already, go ahead and find this document and click on the link. Remember that second page of the introduction section, so that way you have it ready to go. Okay, so then they're going to give you some of those notes, right? So in here, it tells us, activity 1, learn the process of natural selection. So basically what it's telling you is you're going to go back online and you're going to take notes on these next couple of slides. So it's going to kind of, again, review what natural selection is, give you some ideas. There's a term that we are going to be introduced to called directional selection. And then you're going to click and take, right? And then it's going to bring you back to this page. So this is where that lab is going to show up again. So now we're talking about the orange-throated whiptail lizard again. And then it says, in this lab, you will create a model of how natural selection might act on a hypothetical trait of leg length. With habitat loss, the lizards will have to travel farther to find food. Individuals with long legs may be better able to find food than individuals with short leg. And I bring this up because last quarter when we did this, a lot of people were explaining things of the benefits about having longer legs, but they never talked about the actual thing that would create and push this population to have longer legs. And that really has to do with food. People were saying that it's, longer legs lets you go faster from predators, which isn't wrong, but it's not what actually was the driving force behind natural selection. So just be really mindful when you're answering your discussion questions and then your discussion post that's related to this lab. Be really, really mindful about that because it is important to keep in mind the actual driving factor, which in this case is trying to find food. Not necessarily about trying to outrun your predators. Although that is it is a factor, it is a byproduct of it, but that is not the actual purpose. So then once we get into the investigation, they're going to go ahead and they're going to give you a little blurb. And then notice that they do not have that instruction page that I asked you to download on this page. So that's why it's really important that you pay attention and that you go back to that second slide of the introduction, because that's where you're going to find it. Although they are going to tell you the rest of your materials. We do have the lab report, so you are going to be writing the process of natural selection. So they're going to be giving you an idea. If you download that, it's going to bring you to a couple of questions that are going to help you during your thinking of the lab for your discussion post. So make sure that you're downloading that, because that's going to be really helpful to answer, and then that's going to help you write the answers for your discussion post. Well, let's go back to this page, okay? So why don't we go ahead, look through this. What I'm going to tell you already, you're going to want construction paper or printer paper is just fine. But if you don't have it already, why don't you go and find some printer paper or construction paper. You are going to want the measuring tape that's from the lab kit. You are going to want a ruler and scissors and tape. Okay, you are going to want to get all of these. So why don't we go ahead? Let me zoom in here. Go ahead, find these materials, and then let me know when you are all set. Okay, and I'm going to get mine set up as well. So you guys go ahead. I'm going to go ahead and then type in the chat when you're all set, and we'll know to move forward. Okay, so you are going to want the 6-sided die, but you're not going to need it right now, because remember, we're not going through the lab. We're just setting it up. So I'm going to help you guys set it up. And so you don't necessarily need the die, but you are going to want a marker, paper, measuring tape, ruler, and scissors. So go for it. All right, let me know when you guys have everything you need. Here they are. And then I'm going to be right back. I'm going to go ahead and find scissors. No. Oh. All right. Okay, do we have our materials? Did you guys have a chance to get everything? Are we all set? Great, Aiden. All right, how about everyone else? How are we doing? Good. Good, Carly. What else? Who else? Good, Jolene. Madison, how you doing? Got everything? Hillary, how we doing? Great. Okay, so now that we have all of our materials, when we look at our directions, it's really important that we make this the correct way. So this is going to model the two parent lizards, okay? So this entire thing is modeling what long-legged parent and a short-legged parent. So the first thing we have to do is actually create our models. So the way that we're going to represent long legs versus short legs is we're going to be making these little loops, okay? So just like we see here on the page is exactly what we're going to be creating. So what we're going to do is the very first thing is we're going to say for parent one, which has short legs, we're going to cut a strip of paper that is 4 centimeters by 10 centimeters. So what that means is it's going to be 4 centimeters wide and 10 centimeters long. So you can kind of see that right now, right? So it's going to be the thickness is going to be 4 centimeters, but the length is going to be 10 centimeters. So with our ruler, we're going to go ahead and take our piece of paper, and we are going to actually go ahead and write in and measure 4 centimeters. And we want to make sure that this is as straight as possible. So one thing that I do is I use the edge of the paper since it's already straight. So I use the edge of the paper. So all I have to do is actually measure 10 centimeters down, mark it, and then 4 centimeters down like this. And then try to make sure that my ruler is straight when I draw the 10 centimeters down to kind of make that little cut. Okay, so why don't we go ahead and try that? So measure 10 centimeters from the edge of the paper. Okay, and make sure that you realize that the 0 is not the edge of the ruler, right? You need to make sure that the 0 is that first point. So when we're using centimeters, so you're not going to want to use inches. Okay, so I've marked 10 centimeters down the edge, and now I am marking 4 centimeters. Okay. Trying to do this as straight as I can. Going ahead, connecting the 4 centimeter spot to the rest of the page. Oh man, my ruler moved. Okay. Okay, so that's what it's going to look like. That's what I have drawn. Okay. So 4 centimeters down, 10 centimeters across. Once you have that, you can go ahead and cut that out. Take your scissors. You're going to cut out that little strip of paper. And that is parent one. And we'll set it up in just a second. Okay, we're going to set it up in just a second. Right, so again, for parent one, you're going to cut a strip that's 4 centimeters by 10 centimeters. Okay, so let me know when you guys are ready. Just put a ready in the chat when you guys are ready for the next step. Okay, we're going to be starting with step 2. Here's my strip of paper. Okay, ready? Yes, Carly, love it. Who else is ready? All right. Great, Madison's ready. Yes, Jolene. Who else is ready? Yes, Aiden. How you doing, Carrie? Okay. Next step says make a loop. So you're going to take your piece of paper, you're going to make a loop, and then it says overlapping the ends by 1 centimeter. So that just means that this part right here, let's see if I can get this in the camera, this part, they're just overlapping for 1 centimeter. And you can measure it out or you can just eyeball it. You know, I'm measuring mine out. Mine is only 0.5 centimeter, so I have to do more than that. There we go. And I'll measure that again. There we go. That is 1 centimeter. You're going to overlap it, and then you're going to take your tape and you are going to tape the ends together so that you have your loop. Okay. You can use just regular Scotch tape. You can use any type of adhesive, really. You could use glue if that's what's available to you. But you are certainly going to want to make sure that you are connecting the two. Okay. So you should have parent 1. It should look like this. Small little guy. He's got small little legs. Remember, this is our model for parent 1. This is modeling natural selection, right? And this is parent 1 who has the genes for short legs. That's what this is. Okay. Once you've had a chance to do the loop and connect it, the next step is going to be creating a line in the inside of the loop. And that's because when we get into the actual procedure, which again, you'll get to in this week, once you get to the actual procedure, you're going to be turning this every so often. And so that line in the middle is going to tell you when it's been 1 full turn. That's why it's important. So you're going to take a marker or whatever you have handy. Let's see if I have a marker because that way it'll be easier to see. I used to have permanent markers everywhere. Okay, so then you're going to take your marker, and it doesn't matter where, okay? It doesn't matter where you draw it, but you are going to draw 1 black line in the inside of your loop. Okay, and again, this is going to be like when you do 1 rotation, this is going to be where you're going to know if it's been 1 rotation. So it's easier to keep track of. So I did mine with green marker. You can see that mine's in the middle there. Okay. All right. Now we're going to go on to the other one. So now we're going to do parent 2. So if we go back up to the directions, we're on step 4. So for step 4, we're going to do the same thing. Okay, but this time it's going to be 4 centimeters wide, but it's going to be 20 centimeters long. So it's going to be twice as long as the parent 1. And so I'm going to take the same piece of paper, but again, I'm going to do the exact same thing, but on the other side. So I'm going to take my piece of paper, I'm going to take my ruler, and I'm going to measure 20 centimeters down the side of my paper here, and then measure 4 centimeters down. Connect that line, and then I'm going to have my strip of paper. So again, you're going to want to do the 20 centimeters down the line first, making sure that you're measuring it where it's actually 0, not at the edge of the ruler, because that's not where 0 is. So I've got my 20. Okay, so I've marked my 20. I don't know if you guys can see it. And then I'm going to measure 4 centimeters down from there. And then I'm going to connect them down the paper. Okay, so it should be about that long. Okay, I'm going to go ahead and cut it out just like we did for the first one, right? So we're going to go ahead and cut it out. Okay, now we should have a paper this long, right? We're going to do the same thing. It says we're going to make a loop with the strip just like that. And it's going to overlap the ends by 1 centimeter just like the other one. So you might want to go ahead and measure that out, and then you're going to tape it. Okay, so now you're going to have parent 2. You're going to take your marker, do the same thing. You're going to draw a line in the middle of it. Doesn't matter where. Just a way so that when we are turning it over, when we do, like when we move it across the table, which we'll get into in just a moment, you know where 1 full rotation is. Okay. All right. Let me know when you're ready, when you've got your if you got your parent 1 and your parent 2, just say moving on or something like that, so I know we can move into the directions. Great, Aiden, perfect. Great, Jolene. Perfect, Carly. Awesome, Madison. Okay. All right, so moving into this next section. So again, this is going to be the part where we have it set up. So we're not necessarily going to go through it all right now, but I wanted to at least give you an idea of what you're going to do with this. So basically, the second part, so now that we've created our parent 1 and our parent 2, we're going to do the simulation. So we've made our models, right? We're made our models for the different genes. And remember, these are representing the length of their legs. So this is the parent 1, which has short legs, parent 2, which has long legs, right? And that makes sense because what you're going to do, and you'll see in just a second, you're going to move this across the table to simulate the length that's one of the parents has gone. And when we're thinking about the food availability in the urban sprawl, which has caused the habitats to cut down and food is farther away, we're going to see which of these genes is actually going to be favored. When I say favored, I mean that's going to be the gene that helps them survive. Remember that natural selection is all about the genes that helps an organism survive depending on the habitat, depending on the environment. When something changes to the environment, that's when we're going to start to see different traits become more widespread through a population. Another thing that I really want to stress about natural selection and evolution in general. Natural selection and evolution does not happen in one individual's lifetime, okay? So when you watch, like, because I was just watching the docuseries on Netflix called Life in Color, which is actually very fascinating. And I very much recommend that you watch it if you have Netflix and if you haven't before. It's really, really cool. It's about how different animals see the world in different lights. They don't all see the world like we do, right? We see only visible light. They see things in UV. They see things in infrared. Like, it's really, really cool. But part of the series was talking about evolution and talking about these traits that have evolved over a long period of time. And it really bugged me because they kept saying, because evolution changed this, making it seem as if it was like one individual organism was like, hey, it is better if I do this, so I'm going to change the color of my skin. Which, to be fair, there is a couple of animals that can morph in their lifetime. That's part of their genes. That's part of their genetic makeup. Anyway, just be mindful that when you're going through this entire section, natural selection is something that happens through generations of individuals over a long period of time. It's not something that's just going to happen. So, like, let's say I'm a parent one with short legs and all of a sudden my food is farther away. I'm not going to be like, oh, it is better for me to have long legs, so let me just sit here and power, like think about it, and all of a sudden I'm going to have long legs. No. What's going to happen is that a gene is going to be better for survival, and then that gene is going to allow for that organism to survive long enough so that they can reproduce and put their genes into the next generation. And it's going to go over multiple generations before you start to see that this is a more popular, favored trait. So that's kind of what we're going to be seeing here, right? So giving you a really big clue of how to get full credit to show you and demonstrate your understanding. But what we're going to do to simulate that, putting the next generation and more of these traits are going to be put into the next generation, that's when we're going to be using the die. So the die is our representation of chance. And as we go through each generation, we're going to see that the numbers start to represent something different, in this case, favoring a direction. So examine the die. Look at it closely. Each side has a specific number of dots. This is something I believe you have known before. For generation 1, for the F1 generation, the sides with 1 to 3 dots will represent lizard offsprings whose legs are 10 centimeters long. The sides with 4 to 6 are going to represent offspring whose legs are 20 centimeters long. So basically what we're doing is parent 1, parent 2, they're going to be reproducing, and then depending on what number your die lands on is going to represent that offspring gene inheritance that they get. So if you roll 1 to 3, then you have an offspring with short legs. They got the genes from parent 1. If you roll the die from 4 to 6, you get the long legs genes get passed down to that offspring. And then we're going to roll it 6 times. So they're basically going to have 6 offsprings, and they're going to use the data tables to record each type of offspring. So it says, find a clear space on a table or hard surface, place a piece of tape at one end, starting point of your experiment, and then use the parent models to test how far the F1 generation individuals can travel. So a couple of things here. The first thing you're going to do is roll the die, and then you're going to find out how far they can go. So using their genes. So for example, they have the parent 1. So as shown in the illustration below, place parent 1 model at the tape, marking the starting point, making sure the black line is at the bottom of the loop. Remember, that's why we did the black line, to help us determine where we're starting and when one rotation has gone. Roll the model 1 full turn for each individual with short legs that was born in the F1 generation. And then, for example, if 5 short leg lizards were born, roll the 10 centimeter model 5 full turns from the starting point, stopping when the black line is again at the bottom of the loop. You're going to take a piece of paper at the end of that point, and you're going to measure. So I'm using the measuring tape, measure the distance in centimeters. So basically, there is a table, and you're going to be doing this a couple of times. So as you can see, you're going to be doing this 3 times. So let's go ahead and focus on the first one. Now, I'm going to go through it, but that doesn't necessarily mean that you have to. This, again, you can wait until later on this week. I just want to go over what it is you're going to do so that you can be better prepared for once you actually get to it. So the first generation, remember they said 1 through 3, you're going to roll it 6 times. Right? That's what they said, 6 times. So I want to make sure I'm doing everything accurate. Yeah, 6 times. Okay, so you're going to roll it 6 times. Okay, 6 times. I've got, the first one is 2. Okay, so lizards with short legs. Okay, and there's 2. There's 2 tables. So lizards with long legs, lizard with short legs. So far, I've got 1 for short. Okay, so I've got an offspring that has short legs. So I rolled a 2. I'm going to do it again. Another one with short legs. Another one with short legs. Because it's rolled a 1. All right, I got a 5. So now I have 1 for long legs. And I've got 2 more to roll. I've got another short. And I've got another short. So I've got 5 shorts, offspring, 1 long offspring. So now, because the direction said that I'm going to have 5 short ones, that means that I'm going to need to do 5 turns with the short-legged offspring, right? These are short legs. So I'm going to go ahead. I'm going to start at my starting point. I wish I could, let me see if I can show this to you. Can you guys see this? Where is it? Right here. Can you guys see it? So if I start here, and then you roll it once, right? And we know it's 1 time because that line in the loop is back to the ground. Roll it twice, roll it another time, all the way until I've rolled it 5 times. And then I would measure the distance. In this case, I'm just going to guess it's going to be around 45 is my guess. Okay, so 45, and then that's what I would put in this table. I would say that it went 45 centimeters. And then because I've had 1 offspring with the long leg, I'm going to go ahead and roll and do this across. And I'm going to say 1 thing across is 19 centimeters. So 19 centimeters is the distance traveled. Then you're going to go ahead and you're going to start doing this again. So every single time, I'm not going to do all of it, but basically that is the general idea of the procedure. Once you get into the F2 generation, now you're going to notice that there was significant habitat loss for the lizard population has occurred. Now they're forced to travel much longer distances. Individuals with short legs cannot travel as far, and so they have a smaller area of habitat where they can live, eat, and reproduce than with those with long legs. So now what you're going to do is you are going to be doing this F2 generation where you're going to be rolling the die 6 times again, but this time only dots 1 and 2 are for short offsprings, and dots 3 to 6 are going to have offspring with long legs. And then you're going to do the same thing. You're going to go ahead, you're going to figure out however many times you rolled 1 to 2 is how many times you're going to turn the short legs. 3 to 4 or 3 to 6, you're going to roll the long legs and then measure the distance that was traveled. And you're going to do that for the F3 as well, paying attention that the numbers represent something different again. Then you're going to answer your conclusion. Remember, you're filling out your data table. And then you'll have your discussion prompt to do. Couple of things on discussions. It's really, really important that you remember to comment. Not only should you be answering all of the questions that come with the discussion, but you really want to be also be responding. Okay, so responding to 3 other people's posts is probably where people tend to lose the most amount of points. It is the big difference between getting a B and getting an A. You may have a very well worded, very well written answer, but the most important thing is also to remember that you are, in fact, responding to at least 3 other people's posts. And that's going to be a big, big difference, okay? But like I said, today's lesson is just going over the lab. If we take a look at the plan section, and I'm going to be posting an announcement here in a little bit, but if we take a look at our plan section, we can see what's due. So today is May 3rd. I can't even believe. So today you are doing 2.3 variations in population. So you just have one assignment for today. Tomorrow you've got 2. You've got evidence for evolution 1, evidence for evolution 2. And then Wednesday, like I said, you have the lab on Wednesday. You've got 1 lesson on Thursday, and you've got 2 lessons on Friday. And then that unit test is going to be next Monday. Okay, so that's a couple things to look forward to. Tomorrow, our topic is going to be natural selection. Small group is going to be practicing natural selection. But otherwise, that's everything I have for you today. Are there any questions on the lab? Anything that you'd like me to clear up? If you have no questions, then you are free to go. Happy Monday. Great job. Thank you for coming. Hopefully you have a little bit better idea of what to expect with the lab coming up this week, and you've already got what you need, right? You're welcome, everyone. Thank you. Have a great day. Bye now.